So today I am going to be going over the answers to the plane geometry drill. So before you watch this, I want you to give yourself 10 minutes, set a timer, 10 minutes to do as many of these problems as you can. You can look at the chart at the top, which gives the number of questions that you're hoping to get through to get your certain score that you're looking for. Okay. So again, feel free to jump around here to just, look over the ones that you needed help with. All of the answers to this are at the very end of the video, so you can just jump there if you're just wanting to check your answers real quick. Okay, so number 7, Haley wants to install fencing for her paddock pictured below. The 8 sides meet at right angles and the lengths are given in feet. How much fencing in feet does Haley need for her paddock? So this one is actually, might be a little tricky if you don't know how to do it. They're not necessarily wanting you to sit here and find every single length of each one of these, because if you just think about, like, if you just made this into a big rectangle, the amount of fencing that you would need would be the same as what you would need in this situation. So there's 18 on the bottom here, which means there'd be 18 going across the top. If you add these two sides, there's 17 here, which means you need 17 on this side. And so really all it wants you to do is add up those numbers to find your total amount of fencing needed. And that gives us 70, which is C. Number 10, in the figure below, AD represents a straight line drawn through the base of a triangle, and the measure of triangle BEC is 50 degrees. If line segments BE and CE are equal, what is the measure of angle ABE? Okay, so I know that these are congruent, which means that these angles also have to be congruent, which is helpful because I know that for this triangle, they have to add up to 180. So if I call this x, right, so it'll be x plus 50 is equal to 180. I'm going to subtract the 50 off here. So 2x equals 130. Divide by 2. So x equals 65. Okay, so then I'm going to go back up, erase this. So each of these is 65. But careful because they're asking for angle ABE, which is here. So then I just need to do 180 minus 65, and that gives me 115. "17. Yuri would like to install an above-ground circular pool in her rectangular backyard. If her backyard measures 6 yards by 8 yards and she wants to leave 1 yard of grass around the edge of the pool, what is the area of the largest pool in square yards she can install?" So we've got a rectangle that is 8 by 6. We're installing a pool here in the middle where this has to be at least 1 yard and this has to be at least 1 yard. Okay? It's going to be shorter there. So if this is 6 here, then I know all the way across here can only be 4, right, to give me a total of 6. And so my radius then would be 2. So the area of a circle is pi r squared, so pi times 2 squared, so 4 pi, which is A. 20, in the figure below, the small isosceles right triangles are congruent. The area of the square is 324 square inches. What is the total area in square inches of the two small triangles? Okay, so if the area is 324, right, I know that these have to be the same. Okay, so I can take the square root. So I know the area is equal to the side squared, so 324 equals s squared. Take the square root, that gives me that the side is equal to 18. Okay. It also tells me that these are isosceles triangles, so this is also 18 and this is 18, right? So this would be, if I'm trying to find the area of just one of these triangles, it'd be 1/2 times the base, which is 18, times the height, which is 18. That gives me 162. And I know that they're going to be the same. So the 162 plus the 162 gives me the 324. An empty rectangular water tank has a flat rectangular base that measures 2 feet by 4 feet and then has a height of 5 feet. So let's see if we can kind of draw this here. This is a 2 by 4, and then the height going up here is 5. Okay, if 10 cubic feet of water is poured into the tank, approximately how many feet will the surface of the water be above the base of the tank? Okay, so they're giving me the volume of 10 cubic feet. So I know that volume is equal to length times width times height. They're telling me it's 10. The base here is what I'm going to be using. So it's length and width, so it's a 4 by 2. And then the height I need to figure out. That's what I'm solving for. So this is 10 equals 8 times height divided by 8. So that gives me 1.25 is equal to the height, and so that's between 1 and 2. So my answer there is G. Okay, in a given rectangle, the width is 4 units and the diagonal is 2 root 29. What is the length of the rectangle? Okay, so I'm solving for L. The width is 4. The diagonal is 2 root 29. I need to solve for L. So I'm going to be using Pythagorean theorem here. I know this is 4 as well. So I know this is a right triangle because it's a rectangle. So 4 squared plus L squared equals 2 root 29 squared. So 16 plus L squared equals. So careful here. When you take the square root of 29 and square it, that's just 29, but 2 squared is 4. So really you're doing 4 times 29, which is 116. Okay. Subtract 16. L squared equals 100, so then L is equal to 10. In the figure below, sine of y is 12 over 13. What is the value of tangent of y? So this is nice because they're only giving us one angle to look at. So I can go ahead and label my sides, right? There's y, this would be the hypotenuse, this is opposite, and this is adjacent. Oops, can't spell there. A, B, J. Okay, so they're telling me that the sine is 12 over 13. Sine is opposite over hypotenuse, which that's the 12 over 13. So opposite is going to be 12. Hypotenuse is going to be 13. So here's 13. Again, if I look at my answers, I know that my missing side here has to be 5 because that's the only other number. So then the question is, what's the tangent of y? Tangent is opposite over adjacent. Okay, opposite is 12, and then adjacent is 5. So my answer is J. Okay, in the figure below, DE is parallel to AB and FG. CB is perpendicular to AB. If AF equals 4, let me label these in here. CF is 6 and CB is 8. What is the length of FG? Okay, so I'll label that X there. Okay, I'm also going to note that this all the way down is 10. Because I think I'm going to be using my medium triangle and then my big triangle to set up a proportion here. So one thing, if I look at this big triangle here, I know that this side is 8 and this side is 10. That's a common Pythagorean triple that my third side has to be 6. Remember 6, 8, 10. If you did not remember that, you could have just as easily done a squared plus the 6 squared, I'm sorry, a squared plus 8 squared equals 10 squared, and then solved for a. That would give me 6 on the bottom. So now I can match these up, right, because they have the bottoms of these two triangles that I want to use. So x over 6 is going to be equal to, and then I'm going to use my hypotenuse here. So that is 6 over, and then the whole thing is that 10. So then I can solve for my missing piece, right? So 10, x equals 36. Divide by 10, x equals 3.6, which is C. Okay, in the figure below, line segment AB is tangent to the circle with center E at point D. If the length of minor arc DC is 7 pi, so if I want to label that, so DC right here, that length is 7 pi, and EC equals 21, what is the measure of angle DBC? So, or I'm sorry, BDC, so this angle right here. Okay, couple things. One thing that I want to point out, if you have a radius right here with a line that is tangent to the circle right here, those have to cross at a right angle. That is a property with circles. So I know that, you know, off to that side, that is a right angle. I know that, let's see here, this is also a radius, so these two are congruent. And then do I know that that is also going to be 21? No, I'm going to have to use this 7 pi. So let's set up a proportion here. So I can use this, yeah, to find my inside angle right here. So I'm going to say x over 360, because I'm going to solve for that inside angle first, is equal to 7 pi, which is the length of that arc in blue, over, and then I need to find the circumference, which is 2 times pi times the radius, which is 21. Yeah, that's what I'm going to do. Okay, so we'll go ahead and use this to solve for x. That's going to give me my angle measure. Okay, so let's see here. I can divide by pi and simplify this down a little bit. So if I do cross multiplying, I end up with, this is 42 pi equals, so I do, let's see here, 7 times 360, so 2,000, that's not pi, whoop, 42x equals 2520, divide by 42, and okay, I do get x equals 60. So this tells me a couple things here. I know this inside angle, the central angle here, has to be 60. Because these are both the same length, because they're both radii, I know that these two angles have to be the same, and then that gives me that they have to be 60, because I know all three have to add up to 180. So that tells me that this is an equilateral triangle, right? But more importantly, I use this top angle is 60 because I'm trying to find this missing angle right here. I know that this is 90, so the other side has to be 90. So really, I'm just doing 90 minus that 60, which gives me the 30 degrees. Okay, this one was kind of tough. It might be one that you could ballpark and probably at least eliminate 3 of your answers because they are using a couple different properties here that you're going to have to solve for. And then last one here, for all figures in which point O is the intersection of WZ and XY, and WX is parallel to YZ, such as the figure below, which of the following statements is always true? Okay, this one is kind of tricky because all it says that this is that these two lines are parallel here, but it doesn't say that they have to be the same length. So, like, WZ, let's see here, that which also means that, you know, these two don't necessarily have to be the same length. So these you can eliminate, that one and that one. XO is congruent to YO. Yeah, I don't know that either. Angles, though, it's more likely that angles, you know, are the triangles themselves, that they're going to be similar. So this angle one, WXY, so WXY, so this guy here, is that congruent to WZY? No. I don't think there's anything that says that. So now we're down to the last option here. Let's just talk through it. Let's see here. triangle WX is similar to triangle ZOY. So based on what's given, let's see what angles we can label. These are congruent because they're vertical angles, right? Technically, since it says these are parallel, so I know that these two are parallel here, you can kind of think of this as being two separate transversals. So if I start with this one, then these two angles here are going to be alternate interiors, so they have to be congruent. And then these two, yeah, same situation over here. These are going to have to be congruent. Okay, so that means that those triangles are going to be similar because they have the same angle measures, even though they're kind of flipped, right? If you have congruent angles for two shapes, those have to be similar. And so, yeah, the answer here has to be D. Okay, here is the last slide that just has all of the answers that you could check. And then that is it for this week. Thank you.